Imagine this. You wake up not on Earth, but on Mars. Above you is a transparent dome holding back deadly cold and radiation. Your home is a giant module, 3D printed from Martian soil, and just below your feet, tunnels stretch where the first forest outside Earth is growing. This isn't science fiction. It's NASA's and SpaceX's real plan. But can we truly build a sustainable city on Mars? For centuries, Mars has fascinated humanity. In the 1600s, astronomers peered through telescopes and imagined canals built by alien civilizations. Later, science fiction writers filled our minds with stories of Martians and dying worlds. Today, our knowledge is more precise. Rovers crawl across its surface, orbiters map every crater, and scientists study its geology in detail. But the next step is far greater. Humanity wants to transform Mars from a distant dream into our second home. NASA, SpaceX, and scientists worldwide are racing to turn this vision into reality. For some, it's about exploration. For others, it's survival. But Mars is not a gentle neighbor. It is a harsh, deadly world. The atmosphere is 100 times thinner than Earth's and made almost entirely of carbon dioxide. Breathing unprotected is impossible. The average temperature is minus 63 degrees Celsius. Nights are colder than Antarctica, while daytime rarely rises above 20 degrees. Without a magnetic field, cosmic rays constantly bombard the surface. A human standing outside without protection would receive a fatal radiation dose in just a few years. Gravity is only 38% of Earth's, which could reshape bones and muscles over time. And then there are the dust storms, planet-wide events that last for months, blocking sunlight and starving solar panels of power. So how can anyone survive here, let alone build a thriving city? Scientists are exploring a wide range of ideas. One solution is 3D printing from Martian regolith. Special robots could land years before humans and construct massive domes layer by layer, using the very soil of Mars as building material. These domes would shield colonists from radiation and micrometeorites. Another concept is to move underground. Mars is home to enormous lava tubes, hollow tunnels formed by ancient volcanoes. These caverns are stable, naturally shielded from radiation, and could house entire communities. Living beneath the surface might not sound glamorous, but it could be the safest way to survive. Then there's water ice. We now know Mars holds vast amounts of frozen water beneath its surface. This ice could be melted into drinking water, split into hydrogen for rocket fuel, and oxygen for breathable air. In fact, NASA's Perseverance rover already carries an experiment called MOXIE, which has successfully turned Martian carbon dioxide into oxygen. This is the first proof that life support systems on Mars are possible. But survival isn't just about air and water. Colonists will need food. The solution? Closed biospheres and greenhouses. Imagine massive domes filled with crops, where plants recycle carbon dioxide into oxygen while producing food for settlers. Future Martian cities may even include small forests under glass, a piece of Earth transplanted to the red planet. Energy will be another challenge. Solar power will work, but dust storms could shut it down for weeks. That's why scientists are considering nuclear reactors, compact and reliable energy sources that can keep colonies alive through the harshest Martian winters. And before any humans arrive, robots and artificial intelligence will take the lead. They will build the first habitats, set up energy systems, and prepare the planet for human settlers. In a way, the first true Martians won't be humans at all. They'll be machines. But when humans finally do arrive, how will life look? SpaceX imagines fleets of starships carrying supplies and thousands of pioneers. Each starship could bring not only equipment, but also schools, laboratories, and medical facilities. NASA's Artemis program is already testing survival technologies on the moon, where astronauts will practice living off Earth for weeks at a time. These lessons will pave the way for Mars. And the European Space Agency has even proposed a Mars Village, an international city where nations cooperate to build the first settlement. Picture this: a Martian city with neighborhoods of pressurized habitats, greenhouses growing wheat and potatoes, laboratories studying new science, and children playing under a protective dome. Hospitals would treat radiation sickness. Recycling systems would turn every drop of waste into something usable. Life would be difficult, yes, but not impossible. Experts believe that the first real colony could appear as early as the 2030s or 2040s. It might begin as a small outpost with a dozen people, then expand into a settlement of hundreds, and one day perhaps a city of tens of thousands. But this raises a new question. Who will become the first Martians? Will they be highly trained astronauts, military personnel, or private citizens who simply buy a ticket to another world? Mars may be our greatest opportunity to step beyond Earth's cradle. Building a sustainable habitat there will demand every branch of human knowledge: engineering, biology, robotics, and even psychology. Imagine the cultural shift when children are born on Mars, growing up never knowing Earth's blue skies. For them, Mars will not be fantasy, it will be normal life. But can we overcome all the obstacles? Or will Mars remain a dream, always just out of reach? The truth is, humanity has never been closer to finding out. So now the question is, would you leave Earth and become one of the first Martian settlers? Share your thoughts in the comments, and don't forget to like and subscribe to Hypothetica, because more stories about humanity's future are coming soon.